Hi, my name is Megumi Shimizu. I am a field application scientist for environment and food market at SCIEX. I work with customers at their laboratories to set up LC-MS methods and help achieve their goals for mass spec analysis. So today I'd like to talk about our application customer support and customer experience in PFAS world. We support customers from different ways. Once you purchase an instrument from us, you will have access to SCIEX Now e-learning courses. So these are the self-learning online courses that covers software operations to instrument maintenance. And after the instrument installation, one of the field application scientists will visit your lab for on-site training. The training includes operation of instrument, software, and method development. Customers are also eligible to contact our technical support to get virtual assistance for applications, software issues, and minor troubleshooting for hardware issues. The goal of the field application support on-site training is to work with the customers so that customer can operate the instrument with their own method after we leave your lab. This is customizable based on your needs and 100% hands-on experience so that the customers are comfortable operating instrument by themselves. And this is an example of on-site training agenda. After introducing the software and hardware, we usually start working with the compounds that customer is going to analyze. In this case, for you, it's going to be PFAS, and starting with the compound optimization and the source optimization for setting up a method for the customers. We will make a calibration curve and run actual samples if available, so we can practice on the data processing using SCIEX OS. We support a variety of PFAS methods. EPA methods are most popular so far, and many laboratories I visited set up EPA PFAS methods or some modified version of analysis. And we support any methods that meet customers' needs for both nominal mass targeted and targeted analysis and accurate mass for suspect screening or non-targeted analysis. We see expansion of sample types that customers are working on in these days. Now many customers deal with the different types of matrices as we start to find PFAS everywhere in our surroundings. For example, food, biosolids, soil tissue samples, human serum, and so on. With the latest development at EPA, as in the previous presentations, we have many customers now interested in working with the 1633 method and achieving 4 ppq level quantification in drinking water. As a team, we have a great variety of experience, and we continuously learning and expanding our knowledge with the PFAS analysis. And for accurate mass analysis, we support different workflows and acquisition methods, for example, MRMHR for targeted acquisition, and a SWOT and IDA for non-targeted acquisition. For cleaner matrix samples, like drinking water, SWOT, which is a data-independent analysis, is more popular because it can generate MS spectra for all the precursors in the sample. On the other hand, people who are dealing with complex matrix samples tend to prefer using IDA, which results in a cleaner MS spectrum. One of the important part of setting up PFAS analytical method is having an efficient processing method in both quantitative and qualitative workflows. Many customers are usually pleasantly surprised how SCIEX OS is user-friendly and capable of complex data processing. This is a look of quantitative data processing on OS Analytics module. The software allows you easily review the data by samples or by components, also showing a calibration curve using internal standards, also easy to look at chromatogram. And not only setting up a standard quantitation processing method, you can add custom calculations to conduct all the QA, QCs in the EPA methods. We provide canned calculated columns to add to your processing method, and so that you can conduct all the required calculations, such as recoveries of 2 different types of internal standards. So you don't have to export data into Excel spreadsheet and add those calculations afterwards every time you run samples. And instead, you can process methods contains everything, and you will calculate automatically every time when you process the data set in the OS Analytics. For qualitative workflow, we recommend customers to use our fluorochemical MS spectral library for compound identification. The library covers 250 PFAS, and you can also create your own spectral library using standards. And this is an example of MS spectral matching between acquired data in blue and the data from the library in gray color. And often customers ask us how to sort non-target data because you will end up with lots of peaks that picked up, and then people ask how can we sort this large data set and to evaluate how to find PFAS out of everything. And we have a feature called something like a traffic lights. This is a feature allows you to sort large non-target or suspect screening data using a combination of criteria such as mass error or library matching. And you could also use something like a Kendrick's mass defect analysis within SCIEX OS. And this will, we can use a custom calculation in a processing method to calculate Kendrick's mass defect for different repeating units. And we can provide these calculations to help you easily spot some polymer series in the compounds. And all these calculations in both quantitation and in qualitative workflow or filtering criteria are within processing method. So you can save it, and then you can apply the saved processing method every time you process a new data set within just a few clicks. And we work with the customers at on-site training so that the customers have not only acquisition methods, but also the processing methods ready to be used. At both on-site training and technical support, we have we come across many common troubleshooting for PFAS analysis. The most common type is actually contaminations. As we know, PFAS is everywhere, even in laboratories. These can be introduced from sample prep or LC components, mobile phase, or even sometimes nitrogen gas. And the second most common type is often LC related, so gradient program or choice of delay columns and other complex LC setup will need some extra attentions. And actually the most common mass spec related issue for PFAS is source conditions. And some PFAS compounds are more heat sensitive than the other, and some compounds ionize better at higher temperature or higher ion spray voltage than the others. So it is important to know how to decide on the source parameters when you're actually developing methods. For data processing, we see labs that needing custom data reporting or exporting for LIMS systems, so we support these requests as they come. Our goal as application scientists is to support customers to achieve their analytical goals in the most efficient way. So as a team, we have a great variety of experience in PFAS analysis, and we are constantly sharing these information among us so that customers can avoid pitfalls of PFAS analysis and make the most shortcut way to getting the PFAS lab set up. So that's all for